Greetings and salutations, I'm Welbot and welcome to the first episode of Welbot 3D Prints for 2018. Hope everyone's had a safe and happy holiday period. Now if you watched my previous video, you might have heard me mention that I was thinking of doing a project to make a hand mixer to stir the resin in the vat of my DLP printer. And since the model will take a little while to print and cure before I can actually assemble it, I thought I'd do a video about how I created the model while I wait. So this isn't going to be an in-depth tutorial, more kind of overview of the processes that I went through, but if you would like any more information, or if you would like a tutorial of some sort, let me know in the comments and I'll see what I can do. Anywho, enough of my rambling, let's get this party started. Alright, so here we are in Fusion. Now, given that this was pretty much the first time I'd used Fusion, I've got no idea if how I made this was considered to be a normal method or efficient, but as you can tell from the bottom timeline down here, it's quite extensive and goes on for quite a ways, but a bit of the end bit is also putting together the joints and motion links and an animation to show the construction process, or the assembly process rather. But yeah, if we go back to the first step that I did, so we'll roll the history back here. So basically the first thing I did was measured the width of my hand, which would hold the handle, to determine how big the handle would need to be to sort of sit comfortably in my hand, and knew that that would roughly give me a good sense of the overall size that it would need to be. So then I just did some simple fillets and cut a little hole in the end, and given that I wanted this to be completely assembled without any extra parts, I kind of took an extra step of making extra little notches and so forth to make sure that the parts would get held together. So as you can see there, I put a hexagonal hole inside the model, and that's for a plug that will go through the end, and there's a little cutout there because at the top of the main body of it I wanted to slide that into both ends of the handle itself, and then be able to put that plug through both pieces. So that's basically why there's a little notch cut out on both sides of that, which you'll see a bit later on once the body comes into the picture. And I'm not sure if that will work, or rather I'm not sure how well it will work with things like PLA. I'm guessing you'll need a rather robust kind of plastic that can at least bend a little bit. Probably won't have to bend too far, but you will have to slightly bend the body out a little bit to be able to get at least one end into the handle. You can probably slide one end in, and then you'll only have to bend the other end out a little bit to fit in the other side. And then if we roll forward a little bit more, see that this is where I started to make the main body insert that goes into the handle, and then essentially I drew a sketch up here. So that one's basically the profile that I wanted for the body, and then I drew these lines to sweep the body down. And having never used Fusion before, I had no idea sort of how complex a sweep could be. So I originally tried to just sweep it down both paths and hope that it would work, but it didn't quite work. So I'll just unhide these again. So what I ended up having to do was create another profile down there on an offset angular plane, which I then swept down the curve for the vertical part of the body, which is not showing up again. There we go. So yeah, basically that top profile sweeps down that way, and then I basically just copied that sketch, put it on an angled offset plane and swept it down that way. And then I went and just kind of added some extra little fillets in there to make it a little smoother. And then I moved on to the gears, and this is where things got a little bit complex, because I knew that I wanted to make some beveled gears so that I could have one gear sitting vertically and two gears sitting horizontally, and already had a rough idea of how to make beveled gears in a kind of, I guess, a mathematical sense, and from a modeling perspective, but trying to do that in Fusion didn't quite work out the way that I expected. So what I ended up doing was actually looking at user parameters and creating some formulas for it. I'll just skip ahead here in the timeline, see where we're up to there. In fact, I might just skip quite a ways ahead. So that's the end of the gear. Now, basically, what I did was I went into the user parameters and I created all these custom user parameters. So we've got the module and the gear teeth 1 and gear teeth 2, and basically the size of the gear, or the gears themselves, are calculated using those three values. And the way that you get that size is you have to put all these other parameters in as well. You only need one set to begin with, but it's better if you put them all in. And I'm not going to go into exactly what all of these are, but I do kind of have drawings pre-prepped. If anyone does want a little bit more of an in-depth tutorial, I can show sort of what measurements belong to what in the gears. But basically, once you put all of these in, because these are based on formulas, when you put in the value of the module, how many teeth you want on the big gear and how many teeth you want on the small gear, it will then generate the pitch diameter pitch, radius, cone radius, and all that sort of stuff. So essentially the pitch diameter is the measurement of the gear out to not quite the very outside diameter of the model, because what the pitch diameter basically is if we look right down in here, if we can get a decent view. I might just hide that body for a second. Oh, not that one. That one. So the pitch diameter is basically a circle that runs right through here where those two gears actually touch each other. But essentially that's what they call the meshing of the gears, because if the meshing point of the gears, if this gear sat any further in than that, it would actually catch as it turned around, and it wouldn't successfully flow as the gears spinned. So the pitch diameter is basically where the two gears must make contact, otherwise they're not going to perform correctly. So there's basically two sketches for the gear, or for each gear rather, and this sketch here is kind of the sideways profile of the gear. So this is the radius, or half the actual size of the gear, and this is like the side profile of the tooth. And then you use this second massive circle, and depending on the size of your gear will determine the size of that circle, because the dimensions of that are essentially generated by the formulas, and I can show a tutorial on how to do that, but basically most of the dimensions of this sketch you actually enter in as formulas. So you don't enter any sizes during your dimensioning. You enter those values of the gear teeth and the module, and then when you come in here you basically reference those user parameters and enter them in a formulaic way so that it calculates the correct results. Now, as I said, I do have a diagram which I can put up in a separate tutorial if people are interested in that, but basically, to move on from that, this big circle is used to generate these little curves, which are the outer profiles of the teeth. So if you take this curve here and then mirror it on this side, that gives you one of the teeth. So essentially you do that, and then you make a circular pattern all the way around the gear itself, and that will give you the gear. I actually ended up mirroring the big gear to give me both sides of it. Should show up there, and then I basically flattened that out because it kind of came to a point down there which looked kind of weird, so yeah, I flattened that out just to make it a little bit more presentable, and then moved on to creating the rest of the body. So I needed these gears basically in place before I created the rest of the body, because I needed to know how big they were going to be and how big the housing around the gears needed to be. Lift it forward. Okay, so yeah, once I had that part of the body down, I mirrored it to give me the other side, because I knew that I wanted a shaft down the bottom. And as you can see, there's a big ugly second body there, but the reason why I did that was because I didn't want to destroy the original body in case I needed to go back to it, so I created a second copy and then just hid it. So yeah, after mirroring it, putting in a few fillets, I added that shaft for the little bottom, and if we jump forward to there, added another base bit which is going to contain the holes for the shaft, which goes through the little hexagonal hole in the gears. Jump a bit further forward. I don't know why my little scroll things disappeared. Oh. So yeah, you can see I've cut the holes there, and then I originally just cut a hole in the center of the gear, but then I decided I wanted something to give it a little bit more stability within there, so I actually extruded a hexagonal shape which has a hole on the inside for the insert, but it doesn't actually go all the way through the gear. And the reason why I did that was because the handle itself is a two-part piece, so that the crank handle goes in from this side, and then on this side there's another hexagonal insert which goes in there, and then just a little cap to make sure that the insert stays in place. So jump a little bit further forward. As you can see there, I've got a hole cut ready for where the crank handle will go through, and then I started working on the shaft for the beater. So there's a hole and a little extrusion right at the top there where the end of the shaft inserts, so that it's got a little pocket to pivot in, and then basically lofted that into the hexagonal shape which fits through the gear, so that it's got some flat surfaces for the gear to turn around on, and then lofts back into a cylinder for the rest of it. And then, as you can see from the bottom, I've put this little kind of tooth in. Wanted to try and make this in a way that everything could be locked into place essentially without having to screw or glue anything. So I did that, and then put another one on the other side, and roll it further forward. And as you can see here, this part here is the top section of the beater itself, and as you can see, it kind of fits over the top of that tooth, and so you can remove the beater by shifting that up, turning it around until it reaches that point, and then take it off. So this is its seated position, so when it's spinning, obviously that tooth has nowhere to move, so it should be able to spin rather nicely, but it should also not be difficult to assemble at all. Obviously putting it into the resin might push that up a little bit, and given there's that gap under there, I was a little bit worried that it might shift up unexpectedly. So if we roll a bit further forward until the beat is finished, I basically created one beater arm and then did a circular pattern to create the rest. Okay, so to stop the beater end itself from moving up, I created this little clip, which as you can see has just a little angled clip like that. So you put that over the shaft before you put the beater end on, and so if we just move that up, you can see what I did was cut a little angled face there so that the clips themselves will just slide over that nicely and then latch onto the underside of the holder itself. So yeah, that was basically the main portion of the creation. Then I just mirrored the beater end at some point. There we go. And then created a swept circular profile, which also has a hexagonal loft on the end to make sure that it fits inside the hexagonal hole for the gear, so that it's got something to grab onto. And then I created the handle and another one of those angled clips to just slide on there and latch onto the end. And I did that to make sure that this handle bit can rotate freely about this bit here, so that when you turn the crank, it doesn't grip on your hand, as it were. And then created the end cap for the other side, which you can just see going through the gap into the hexagonal hole there. And then lastly, if we can find it, I went and created these top end cap bits. And from there, just to make sure that it all worked, I moved on and created a whole bunch of joints and motion links. I'll just go right back to the end here. And so now if I rotate this handle, you can see that it's all working nicely. Nothing clashes into one another. And the gear ratios are set correctly. So one turn of this big gear would, like how many turns this gear would turn, basically take the number of teeth and divide it by the amount of teeth on the smaller gear, which gives me about 3.33 or so. So when you create the motion link, you type that value in, and then when you move the handle, everything works correctly. And if we zoom in a bit, it looks like it's a bit out of alignment now. Something must have shifted at some point. Yeah, I think I must have accidentally pressed something. Oh, there we go. So if we turn the handle, you can actually see that the teeth are meshing correctly. It's a bit jiggly trying to do this in here, but that was the main reason why I went through and set up these joints and the motion link, was to make sure that these teeth do in fact mesh correctly as they go around, because otherwise the entire thing's not going to work. So with that kind of proven, I then moved into the animation environment and created this assembly animation, which basically shows the model completely exploded and then sort of zooms in and shows everything being assembled. So if you do print this off yourself, and you're curious about how it actually goes together, you can watch this animation and it shows it all being constructed. So there's that little tooth latch and then the clip coming down to hold it all into place. And this bit here might be the only bit that people may have problems with, because it depends on how good the tolerances are on your printer, and how much shrinkage you get, I guess, as to whether they're going to be a tight fit within the gears and hold the handle in place. But that should be the only kind of troublesome spot, apart from maybe that handle insert which you saw at the top there. So as you can see, I slid that handle in one side, and obviously you'd have to bend the other side out to slot into the other end. Shouldn't require too much bending, but depending on how strong the material is that you're working with, will depend on whether it's going to work. Given that I'm printing this with a resin, I know that most of the models I've printed so far can cope with that kind of bend, so I'm not worried about it in that sense. But given that I don't have an FDM printer, I'm not sure how bendy those parts can be, but I'm certainly interested. If anyone wants to give it a try and show me the results, I would be very keen to see. Alright, well, there you have it, guys. Hope you've enjoyed seeing how I created this model, and I will of course do a video showing my final printed results and the assembly. But in the meantime, if you have any questions, you can leave comments below, or you can contact me via my Twitter handle @TheRealWelbot, or on facebook.com/welbot3dprints. Now, I've also uploaded the model to Thingiverse, so if anyone else wants to have a go at printing it or modifying it, you can grab the files from the link in the description below. And of course, I'd love to see the results if anyone does attempt to print it, especially if you do it on an FDM printer, as I don't actually have one. So it'd be great to see how the results turn out compared to doing it on a DLP printer. And don't forget to subscribe and like the video if you want to see more stuff. And if you'd like to support the channel, you can make donations to paypal.me/welbot, which will help me a great deal. But of course, if you do wish to support but you have other preferred methods like Patreon or whatever, let me know and I'll see what I can do. I haven't really looked into any of that stuff yet, but if you would like to support me in that way, I can certainly look at setting something like that up. Also, before I go, I recently acquired these UV LEDs, which I plan to use to make a curing box for my models. So if you would like me to document the process and make a video about my success or failure with making that box, let us know, and I'll make sure to do a video and put it up for everyone to see. Alright, thanks for watching. Catch you next time.